Hey class, today I want to talk to you about adding fractions. I want to make sure that we make this next step to where we're adding fractions with uncommon denominators. But first, let's kind of review what we know already. We already know how to add fractions if the bottoms are the same, if the denominators are the same. All right, so if I've got 1/3 and I want to add 2/3, we know how to do that. The bottoms are the same. You say, okay, I have 1 out of 3 parts plus 2 out of 3 parts. I now have 3 out of 3 parts, which is what? It's the whole thing, right? I now have a complete whole one. All right, so we've done that with these common denominators. But now you're going to be seeing ones where the fractions don't have common denominators. So for example, maybe I have 2/5 and I have 6/10. All right, 5 and 10 are not the same. If I want to add or subtract them, there's nothing I can do, right? Well, there is something we can do. We can try to get the same denominator. We can look at it and go, what would I have to do to this 5 to get a 10? All right. Might even pull out my multiplication table and go down 5 and look for a 10. Oh, right there's a 10. Look, 5 can become 10 if I times it by 2. Now here's the trick. Whatever you do to the bottom, you got to do to the top, or you'll wind up with a faulty fraction. You'll wind up with a fraction that's not the same as what you started with. I'll show you why that is here in a minute. So I decide I'm going to times it by 2. Whatever I do to the bottom, I do to the top. 2 times 2 is 4. 2 times 5 is 10. I'm kind of rewriting my fraction here. I'm going to be adding that to 6/10. Okay, and again, look at this. 4 plus 6, that's 10. And then my bottoms don't change when I'm adding or subtracting. So I have 10 out of 10, which again is the whole thing. It's one whole. Got all the parts I need to build the whole thing. Let's take a look at what I was saying here about changing a fraction up here. So let's say I've got 1/4. Okay, and I decide I'm going to times it by 2, which would be 2/8, right? 2 times 1 is 2, 2 times 4 is 8. So my 1/4, okay, that would look like this. Here's my candy bar. I divide it into 4 parts. I've got 1 part. Okay, my 2/8 got the same candy bar. This time I'm going to divide it into 8 pieces. So let's see, let's do that, and that, and that. Now I've got 8 pieces. Imagine those are the same. I know they're a little bit different. But I got 2 pieces now. So I got that piece, and I got that piece. But you can visually look at this and tell that these 2 pieces are the same as having that 1 piece. They're just smaller pieces. And that's how I know that 1/4 is the same as 2/8. Okay, they're the same fraction, they just look different. We've just cut this one up more, but it's the same amount of space that I have. Okay, let's take another look at some of these unlike denominator fractions. Let's go with, I've got 5/6, and I want to get rid of 1/8. Okay, oh boy, not the same denominator. So you got to think, well, how can I do this? These are a little different, right? A 6 can't become an 8, and 8 can't become a 6. So then I got to look at something. I got to say, well, what can they both become? Maybe I can change both these fractions to something that's the same. So I'm looking down my 6's, I'm looking down my 8's, I'm looking for any numbers they have in common. They both have a 24. So the 6 times 4 becomes 24, and the 8 times 3 becomes 24. And again, whatever I do on bottom, I got to do on top. Bottom, top, same thing. Keep the fractions the same, they just are going to look different. 4 times 6 is 24. 4 times 5 is 20. Over here, 3 times 1 is 3. 8 times 3 is 24. So now I've got it set up 20 24ths minus 3 24ths. Well, if I have 20 parts and I lose 3 of them, okay, I now have 17 parts out of 24. And that's just subtraction. I just subtracted 3 from 20. All right, one more example and I'll set you loose for the day. Let's do the same thing with, we'll do it with addition, okay? So let's say we've got 5, do 2/5. Let's say we want to add 1/3 to it. All right. So again, we look, 5 can't become a 3, 3 can't become a 5, but what can they both become that's the same? So I'm looking down my 3 and my 5 columns, looking for anything they have in common. Oh look, they can both become 15. 5 becomes 15 by timesing it by 3. 3 becomes 15 by timesing it by 5. Okay, 3 times 2, that's going to give me 6. 3 times 5, that's going to give me 15. We'll be adding that to 1 times 5 is 5. 3 times 5 is 15. So that's 6 out of 15 parts plus 5 out of 15 parts. 6 and 5, that's 11 out of 15 parts. Again, when you're adding and subtracting, once you get the bottoms the same, they stay the same. Okay? Hopefully this will help on today's assignment. Make sure that you raise your hand and ask for help if you're not getting it. We're doing a lot more of these coming up. Okay? Good luck.